Hi, my name is Hamza Hassan, and this is my IPD for my final year project. So, in the project, I'll be evaluating AWS Lambda and Lambda Edge, but not just in terms of raw latency, but in terms of more of an architectural point of view, looking at the architectural trade offs. So, when edge computing is actually justified and when it isn't. The motivation behind it. So, modern applications serve users globally, but serverless execution is still often centralized. Edge computing promises more improvements in terms of latency mainly, but it still introduces other aspects such as complexity. It can introduce deployment friction, limited observability, and also debugging issues. So rather than just assuming Edge is always better in this project, I will look to ask a more critical question, which is when is Edge actually worth it? Moving on to the stakeholders. Here you can see there's different stakeholders. Different stakeholders in an architectural point of view value different system properties. So, for example, the end users, which are the website visitors, they would care mainly about responsiveness, um, having lower latency when interacting with the web page. Developers would care about debugging and also sorting out any debugging issues, and the architects or engineers would care about trade-offs. So in this project, I'm trying to consider all of these perspectives, all of these aspects, so that I have more of a clear evaluation, but more in a architectural sense of it. So not just in performance, but also considering all of these aspects. After feedback with my supervisor, based on the PRS submission, I chose to refine the scope and the project a bit more. So, with regarding external APIs, I chose to remove it. So I was going to previously use Open Weather API. So now I've excluded it from here, and now looking at it, it does eliminate any variability. So the project now is more redesigned to be fully AWS native and also a more controlled environment. So the focus now, the main focus that I have now is has become a more geo personalization of static content, which is more of an area where Lambda Edge is realistically used. And also I've taken out VPNs, which I would explain later on. Functionally, the systems perform geo-based routing using identical logic in both architectures. Non-functionally, the emphasis is more on repeatability. So I want the environment to be repeatable so I can run repeatable tests. Scalability, which is also for testing wise. Security, which I've used for IAM. And critically, an explicit, clear observability trade-offs. So this is the first architecture, as you can see. This is the edge-based architecture, Lambda Edge. This diagram here shows the Lambda Edge execution flow, which is going to be used in the project. So a HTTP request from the client reaches the CloudFront at the nearest edge location. Then Lambda Edge executes at the viewer request phase, which means basically it runs before CloudFront makes a cache decision. And at this point, the function reads it would read the viewer country, the CloudFront viewer country header, and rewrites the request URI to a specific region page. So the specific pages that I've set out is UK.html, which is for the British users, and then I also have SG, which is Singapore, US, which is USA, and AU, which is Australia. Then also I have the index.html, which is the default page. So because the URI is rewritten before the cation itself, the rewritten path becomes part of the cache key. So this is really important because it allows CloudFront to cache different regional variants independently at the cache. Also, during the testing and um, whilst I was building it, I deliberately bypassed and disabled CloudFront caching for mainly I'm going to be doing that for tests, but I disabled it, which would get rid of this aspect of cache hit, which would actually remove any sort of integrity because we're focusing on edge-based computing. This allows me to isolate that behavior of Lambda edge itself, so such as request mutation, rotating correctiveness, and just invocation behavior, so I can analyze the edge-based function more without any cache-based responses. So once that baseline is established, then caching can be re-enabled. I would be able to compare cache miss against cache hit, which is something that I'm going to be looking at. And then I can also observe how caching may shift or work away from the origin, and it could further improve response stability. So this interaction between edge and edge-based compute and the caching is the core justification for using Lambda Edge in this project, rather than simply relying on a regional function. The second architecture, which would be for the regional Lambda, this architecture uses an API gateway, which is also regional, and a regional Lambda as the baseline. This is the baseline. And it implements the same routing logic, but without any edge caching. And also it has full observability with CloudFront compared to Lambda Edge, which has more of a limited observability. So the internal differences between Lambda and Lambda Edge is that Lambda Edge trades observability and simplicity for cache proximity and also distribution. Whereas in contrast, the regional Lambda would offer more of a deeper visibility, but more of a centralized regional execution. So a key takeaway is that client-side measurement becomes the only consistent observability mechanism for Edge. So that's the only way we can sort of observe. Mainly is the client-side measurement of it, which we would be using Postman for. Now for the cache behavior and cold starts, so I'm going to compare cache hits and cache misses, which I explained earlier. For regional Lambda, cold starts are more directly observable via CloudFront, whereas a Lambda Edge cold behavior is discussed more as a limitation. It's more seen through client visible latency. So it just shows the differences, how observability is different between both functions. Now, the progress that I've made now, so at this stage, the project or the prototype is fully functional. Both architectures route correctly, and the S3 bucket is also private with origin access control. So it can only be accessed. It's not out for the public. It's not publicly accessed. And also the behavior can be inspected through curl, through headers, and also CloudWatch when applicable. Also, what I discussed earlier, instead of VPNs, geographic routing is simulated using query parameters. So I'm going for more of a query parameters approach to it, which would remove any sort of network noise. It allows identical routing logic to be tested repeatedly. So the goal is just to see and evaluate the architectural behavior of both systems, not real-world geographic latency. And it's more controlled and it's more repeatable. Sorry, I went up. Now the testing methodology behind it. So Postman Runner is going to be used as the primary testing tool. So I deliberately separate measurements into client-side, protocol level, and service level measurement. This ensures repeatability and allows meaningful comparisons, even when where the internal observability is limited. So as you can see here, the service level measurement, which would be mainly for the regional Lambda, would be CloudWatch, which will look at the init duration and also the execution duration. Curl is also going to be used, and also Postman runner, and also the browser, just for functionality, just to look at how it's functioning more visibly. Now the research and evaluation questions. So due to after feedback, I went back and tried to find questions that I could, instead of me just retrieving metrics and collecting metrics for their own sake, now the project's more driven behind research questions. So these focus on the latency behavior, predictability, cation effects, and also just the trade-offs, the architectural trade-offs between both. So here, these are the questions for performance behavior, these would be for predictability, and then also the architectural trade-offs. And then here is how also I've mapped the research questions to measurements, and also why it would be valid, why it could be valuable to this project itself. So each research question is explicitly mapped to a method. This ensures that conclusions and research is actually defensible, so I can defend it through this, and also it's directly supported by observed behavior. Now constraints and limitations that I have in the project would be that there's limited observability with Lambda at edge compared to more of a regional Lambda, aggregated metrics mainly, and there's no real world network measurement. So it's more, these are more acknowledged and accounted for rather than ignored. I have to consider these limitations and constraints. Why edge in this project? This is something that I had to think about. So edge is mainly justified here because request mutation happens before the cache lookup. This allows routing logic to actually shape the cache behavior, which cannot be achieved with just regional Lambda. So why edge without strict SLAs? Essentially, not all systems operate under strict latency SLAs. Architectural decisions are often made heuristically. So this project, I'm trying to evaluate whether edge is justified even in those cases, whether regional Lambda is justified in those cases. So it's just to see which function is applicable in each use case. What this project doesn't claim, so I want to be clear about this project. This project doesn't claim and does not measure real-world global latency. It doesn't replace production monitoring. Its contribution is more of architectural insight into both systems and both an edge compute compared to a regional compute. So the current status of the project now and the next steps. So now the prototype's completed, the architects are validated, and the testing framework is defined. So now I have these questions set out. So the next step is the full benchmarking and statistical analysis in the final year submission. Thank you.